You know the feeling, right? You've built this beautiful Delphi application, but then you go to load a bunch of data, and it just grinds to a halt. The screen flickers, the app freezes, and you start to sweat. Well, what if I told you the fix is often just 2 lines of code? Let's dive in and turn that sluggish UI into something incredibly fast and fluent.
So, here's our game plan. We're going to start with the problem itself, the flicker and the freeze. Then, we'll reveal the simple but crazy powerful pattern that solves it. We'll geek out a bit on the differences between VCL and FMX, cover some pro-level tricks for those tricky components, and even figure out what to do with truly massive datasets. By the end, you'll have a complete playbook to make your apps fly.
All right, first up, the flicker and the freeze. This is that moment your app's performance just hits a brick wall. And yeah, it's a pain every single one of us has felt.
So what's actually happening under the hood? I mean, why does something as simple as adding items to a list box or a combo box make your whole application feel like it's stuck in mud? It's the question that's haunted Delphi developers for ages. And here's the bad guy. It's actually pretty simple. If you don't do anything, every single time you add an item, you're basically yelling at the UI, hey, stop whatever you're doing and redraw yourself right now. Now imagine doing that 10,000 times in a row. The UI gets flooded with these repaint requests and it just can't keep up. That's your freeze. That's your flicker.
And this isn't just theoretical. Check out this real-world quote from a developer, Jerry Dodge. He tried the standard fix, and sure, it helped. It shaved a second off a 6-second load time. But come on, a 1-second improvement just wasn't the game changer he was looking for. This tells us something important. The basic solution is a great start, but to get real results, you've got to understand what's going on.
Which brings us to the good part, the solution. Section 2 is what I like to call the do not disturb pattern. And trust me, it's incredibly simple, but the impact is absolutely massive.
The heart and soul of this solution is begin update and end update. The best way to think about it is like putting a do not disturb sign on your component's door. Begin update hangs up the sign. This tells the UI, hey, I'm about to do a lot of work. Just ignore everything until I'm done. You can then add, delete, or change thousands of items, and the UI won't even blink. Then, end update takes the sign down, and that triggers one single, super efficient repaint to show the final result.
Now, if you want to see just how dramatic this is, just look at this chart. We're loading a little over 2,000 items into a FireMonkey list box. Without our little pattern, it takes a painful 25,000 milliseconds. That's 25 seconds of your user just staring at a frozen screen. But with begin update, that time drops to just 125 milliseconds. It's not even close.
Let that sink in for a second. A 200 times performance improvement. We're not talking about a little tweak here. We're talking about going from a totally unusable 25-second wait to something that feels instantaneous. This is the power of the do not disturb pattern. Seriously, it's the difference between an app that feels amateur and one that feels professional.
Okay, so we've seen the incredible impact, but how does it actually work? Because under the hood, the VCL and FireMonkey frameworks actually pull this off in 2 completely different ways.
It all comes down to their architecture. You see, the VCL is basically a really nice wrapper around the Windows API. So when you call begin update, it's often sending a special Windows message, WM_set_redraw, directly to the operating system. It's telling Windows itself, hey, stop painting this thing for a minute. FireMonkey, though, is cross-platform, so it can't rely on Windows. It has its own rendering engine. So in FMX, begin update just flips an internal switch, a little flag called fupdating, which tells its own engine to pause not just painting, but also all those expensive layout calculations.
Okay, you get the basics. You're ready to use begin update everywhere. But wait. To really master this, you need to know about the common traps that people fall into and a few specific tricks for different components. Let's get those pro-level results. And here is a classic gotcha. A developer tries to be good and optimize their T-string grid. They type it in and begin update doesn't exist. It's that moment of pure frustration. But don't worry, there's a way around it. You just have to know the secret handshake. For a T-string grid, the method isn't on the grid itself. It's on the .rows or .cols properties. They have the begin update you're looking for. Now, for T-memo, this one's tricky. Calling begin update on .lines does almost nothing. The pro move here is to build your text in a separate T-string list in memory, and then, bam, assign the whole thing to the .text property in one go. And for something like a T-tree view, this is absolutely critical.
Otherwise, the control tries to recalculate its entire complex tree structure every single time you add one tiny node.
Okay, everybody lean in. If you remember absolutely nothing else from this explainer, remember this slide. This is the golden rule. You must, always, wrap your update code in a try finally block. Why? Think about it. If some error happens while you're adding your items, your code could crash and jump out of the procedure. If that happens, end update never gets called, and your component is now permanently frozen. The finally block guarantees, no matter what, that end update will be called. This is completely non-negotiable if you want to write stable professional code.
So far, we've been focused on stopping the UI from redrawing itself over and over. But what happens when your data set is so ridiculously huge that drawing isn't even the problem anymore? What happens when just the memory becomes the bottleneck? Let's talk about the final frontier of UI performance.
Yeah, there's a tipping point. It's usually somewhere around the 50,000 item mark. At this scale, even with begin update, the sheer act of allocating memory and adding that many items to the control's internal list takes forever. Your application will still freeze, and you're going to need a whole new strategy.
And that strategy is called virtual mode. This is a complete mind shift. In virtual mode, the control stores absolutely nothing, no data, zero. You just tell the list view, hey, you are responsible for displaying 1 million items, and it just says, okay, got it. It doesn't load a thing. Instead, when the user scrolls, the control comes back and asks your code, okay, I need to show item number 500,005. What text should I put there? You provide the data on demand only for the few items that are visible. The result? The load time is basically instant. It's pure genius.
Whew. Okay, we've covered a ton of ground, from the simple problem all the way up to advanced architectural patterns. So now, let's pull it all together into a clear, actionable playbook that you can use on your very next project.
Here it is, your checklist. Number 1, and I'll say it again, always use try finally. 2, do all your heavy lifting, your database queries, your calculations, before you even start the begin update block. 3, know your escalation path. Start with begin update. If that's not enough, especially in VCL, you might try lock drawing. And for the huge stuff, go to virtual mode. 4, a great pro tip, set the dot capacity of your string lists before your loop. This stops it from having to resize itself over and over, which can be a hidden performance killer. And finally, number 5, always remember that FireMonkey is extra sensitive to this stuff because of its layout and styling engine, so be generous with your locks in FMX.
So after all that, we end with this question. Because at the end of the day, UI optimization isn't just a technical thing to make numbers go down. It's a fundamental part of the user experience. It's a sign of real craftsmanship. It's about respecting your users' time, their patience, and their attention. So is your code doing that?